Hello, my name is Sean Scarlett. I'll explain how to design a mobile audio system which is small, low noise, and cost-effective. These are common hurdles that are difficult to get over in any audio system. The solution for cell phone handsets would also be ideal for other devices, such as tablets and e-readers, personal navigation units, and portable media players. All of these have some common requirements for good sound quality during playback of voice and music. They are all power sensitive, so they require efficiency, both in their amplifiers as well as their transducers. There is also very limited space, which means the ICs need to be as small as possible with few external components. And the driver needs to be as thin and as small as possible, while still being capable of producing the sound levels and frequency required. Most of all, the solution needs to be cost-effective. In particular, today we will focus on the TFA9881 and TFA9882. These amplifiers both feature embedded control and dynamic power stage activation, making them the smallest and most efficient in the industry. The difference between the two is the input format. The TFA9881 features PDM, or pulse density modulated input, and the TFA9882 features the more standard I2S format. Now, why would you want to choose a digital input? The primary reason to choose a digital interface is the robust immunity to RF interference. This graph shows two similar Class D amplifiers, one with an analog input, shown in red, and one with a digital input, the TFA9879, shown in blue. For each of these amplifiers, we bought a cell phone in transmit mode, close to the demo board. I think many can predict the sound that the analog system will make. This sound, sometimes called GSM noise, or bumblebee noise, is caused by the RF interference being picked up on the input trace of the amplifier and being amplified with the rest of the signal. By switching to a digital amplifier, you eliminate that pickup. A digital input can also eliminate the need for a digital to analog converter in the system. You can take the audio output from the chipset straight to the amplifier. It also means there's a much easier layout. Ideally, you want the amplifier as close to the speaker as possible, and with a digital input, you don't need to worry about long analog traces on the circuit board. And instead, the digital traces can be routed with other digital lines where convenient. The TFA9881 and 82 are the smallest digital input amplifiers available in the industry. They do not need external filters in the output, and they utilize embedded control tokens, which eliminates pins and allows the device to fit into a 9-ball chip scale package. They feature dynamic power stage activation, which allows them to offer the lowest power consumption in the industry, as well as the lowest quiescent current. The solution we will show you is based on using the output of the chipset, or codec, to drive the TFA9881. Or you could substitute the TFA9882. In cases where you need a robust system-level ESD protection, the PESD5V protection diodes are a perfect choice, as they are available in small packages. The demo setup you see here is the TFA9881 with a controller board attached to a computer, which helps generate the data stream and the embedded control tokens we'll be talking about in a moment. Embedded control tokens eliminate the need for separate control, which reduces the pin count on both the amplifier and the chipset. It also allows the part to shut down when no input signal is present. A typical amplifier uses an I2S signal path feeding the amplifier, and then a separate 3-wire control interface, typically using I2C, that allows for setup controls, turn on, turn off, and mute codes. The embedded control uses the first numbers that come to the amplifier as optional setup codes based on unique identifiers. Then the signal path transmits the audio data stream. When the data stream ends, the part will automatically shut down. Inside the signal path, you can embed specific tokens to mute or unmute the device. And once again, when the data stream ends, the part will automatically shut down. Both of these products feature dynamic power stage activation. This is a system where only the portion of the output stage that are required to produce the needed current are turned on. So in most applications, it will use only 1/4 the quiescent current as a typical Class D amplifier. We'll start audio playback with a moderate level signal. This would be something along the lines of what you would normally be listening to. As you can see, only the portion of the device that is needed is on. The rest is shut down, saving power. Both the TFA9881 and TFA9882 also feature output slope control. In cases of difficult system requirements, or where there is an EMI issue in the system, you can activate the slope control and reduce the EMI by 10 dB. There is no noticeable impact on the sound quality or system performance. It works by slowing the output transition during the switching. As you can see in the scope, the slope of the switching is near vertical with the control off. This is the most efficient setting. With the slope control on, the rise is noticeably slower, reducing the EMI radiation. When we look at this over the broadband spectrum, we can see that there's a dramatic reduction in the broadband radiation. To summarize, the TFA9881 and 9882 are the perfect fit for portable devices due to their very small footprint, their immunity against RF interference, their low power consumption, and their low EMI radiation. For more information, please visit our website at nxp.com.